Hello students, welcome to this new session of electromagnetic fields. Today we will see examples on Coulomb's law. So its continuation part we will continue in the next session. Today we will solve few examples of various types. So let us begin with our discussion. So this is our today's first example. In example, as you can see, we have given a 2 millicoulomb positive charge which is located in vacuum at point 1. Its location is 3 minus 2 minus 4, and there is another 5 microcoulomb negative charge is given which is present at some other point. Location is 1 minus 4 2. We have to find out the vector force on the negative charge and what is the magnitude of force on charge P1. So how it is looking, we will let us draw the diagram for this. Say here we have one charge. Say this is charge P1. Say this is P1 here. So from this P1 we have to find out what is the force given on some other point which is present in space. It is given by, say, P2. What are the locations of P1? These are 3 minus 2 minus 4. So here we can write down the location. It is 3 comma minus 2 minus 4. These are 3 coordinate points. What are the points for P2? P2 is 1 comma minus 4 comma 2. And how much charge is present on P1? P1 we have 2 into 10 to the power minus 3 millicoulomb. And on P2 how much charge is there? We have minus 5 negative charge. So it is given by 5 into 10 to the power minus 6. So this is the setup for our example. So here we can imagine the system. Now first part we have to find out the vector force. So here let us write A we have to find out vector force on the negative charge. So negative charge is minus 5. So how we do? Our formula is Q1. What is force? How we find out force? Vector force, that is F bar. So it is given by the product of two charges. So we have two charges Q1 Q2 divided by 4 pi R square. This is the formula. So in this formula we can keep, and here we have to add the direction component. Say AR cap. When we write vector we have to add the direction. So this part is magnitude and this part is direction. That is the whole vector. So let us put all the values. So F bar is equal to, we have Q1. Q1 is 2 into 10 to the power minus 3 into Q2. What is Q2? It is minus 5 into 10 to the power minus 6 divided by 4 pi is constant, epsilon naught value is also constant, R the distance between them, R if we calculate it will get a value of, say, 6.633. How to calculate R? R we have seen in the previous examples. So what is AR cap? AR cap is unit direction. It will be equal to vector divided by the magnitude. So we can write down the vector is nothing but the destination points minus source point. So what are the destination point? 1 minus 4 2. These are the destination points. So first we will take this 1 and source point this 3. So what will be the AX component? 1 minus 3, destination minus source. In which direction? In AX direction. Then next one, plus. Second destination point is 4. So minus 4 minus second point here is minus 2. So it will become plus 2. Which direction? AY cap. The third one remaining is 2 minus 4 means it will become plus 4. So here we can write plus 2 plus 4 and the direction is AZ cap. And below that the magnitude. Magnitude will be square root of minus 2 square plus minus 2 square plus 6 square. How we got this minus 2? 1 minus 3 minus 2. Minus 4 plus 2 minus 2. And 2 plus 4 is nothing but 6. So this is AR cap. So how we got AR cap? If any student doesn't remember this formula, I will write down here. Basically all the vectors are nothing but the product of direction and magnitude. So vector is equal to what? Magnitude into direction. What is direction? Direction is AR cap. So what will be AR cap? Equal to vector divided by magnitude. So it will be, what is vector? Say AR bar is vector and magnitude of AR bar. And how we calculate this one? This is nothing but destination points minus source points. So this is how we calculate AR cap. So after calculating these values, you can cross check in calculator. Always in the session you should sit along with a calculator and you should calculate the values for the practice. So for reference, I will write down here the values of answer. You will get 0.616 AX cap plus 0.616 AY cap minus 1.848 AZ cap. So this will be the force. So this is part 1. So now let us move to part 2. So part B we have to calculate now. So here we will calculate for part B. Part B, what we have to find out? What is the magnitude of the force on charge at P1. Now charge at P1, that is nothing but magnitude of force on, how we calculate any magnitude? It is nothing but square root. So already we have calculated the force. From force we got the values. Its magnitude is square root of those values. So what we got? X we got as 0.616 whole square plus 0.616 whole square plus third value is minus negative. It is minus 1.848 whole square. So this will, once we calculate, we get this value as 2.043. This is the magnitude of force. Force unit is Newton. So this is our answer of part B. So now this is the first example. Let us see another example, 2.2. Here we have to calculate E bar at some point M, and M is located at 3 minus 4 minus 2, right, in free space. Now we have to find out E bar, that is electric field caused by a charge Q1 that is located at some origin point where X, Y and Z, all of them are zeros, and from another charge Q2. Q2 is 3 microcoulomb. It is located at some place where X is minus 1, Y is 2 and Z is 3. And third one, we have to find out for the charge Q1, 2 microcoulomb again. This is also present at the origin. And a charge Q2, 3 microcoulomb at P2. Right, so P2 points are given -1, 2 and 3. So we have to find out electric field intensity. So for first case we will draw the source and destination. So to solve part A, so we have to find out force on M, due to whom? First it is due to Q1. So let us consider, here we have Q1. What is the value of Q1? 2 microcoulomb. So we can write 2 into 10 to the power -6. This is our Q2. Where it is present? It is present at P1. So P1 is at origin 0, 0, 0. So this you have to imagine in 3D based on our discussion in the previous session. And we have to find out effect on some point M. Where is the point M? The destination points are at 3, -4, 2. Right? And how much charge is present on that? It is not given. Directly we have to find out the electric field intensity. Electric field intensity is defined as the force per charge. So what is force formula? Force formula is, say, Q1 Q2 divided by 4 pi epsilon naught r square into AR cap. Now here we have to find, say, suppose this is Q1 and this is Q2. So Q1 Q2 per some charge. So here we will get, say, additional Q2 or Q1 depending on the destination. So this one will get cancelled. So we will get formula as Q by 4 pi epsilon naught r square into AR cap. So we need one single charge who is applying force on the another charge. So force per charge is the formula. So we can keep the values and find out this electric field intensity. This will be equal to, what is value of Q? Now for A, value of Q is, for Q, what is our Q here? 2 into 10 to the power -6 divided by 4 pi epsilon naught, and our R magnitude by finding out the source, destination minus source, and magnitude, we get a value of 5.385 whole square. Now this is magnitude. Direction is again calculated by the same method, vector divided by magnitude. And how we find out the vector? It is given by destination points minus source point. So destination point is, first one is, say, 3, and first source point is 0. So it will be 3 minus 0 into AX cap plus second value is -4 minus 0. This is AY cap plus third value is 2 minus 0 AZ cap, and the magnitude will come to, 3 minus 0 is 3, so it will be 3 square plus -4 minus 0 will be -4 whole square plus 2 square. So after solving this we get 345.307 AX cap minus 460.409 AY cap plus 230.204 AZ cap. So this is the solution for first part. Now let us solve for part B. Here we have a charge given Q2. For this Q2 we have to find out the effect on M. So now let us draw this diagram. So for this we have one same source point, it has 3 microcoulomb. So here we are calling it as, say, P2. This location is P2. Let us change the color. So here P2 is there. From P2, the force is applied on the sample point M. What are the location of M? 3, 4, 2. This is destination. What are the source points? Source points are at P2, it is -1, 2, 3. And charge on P2. Charge on P2 is, that is Q2. It is 3 microcoulomb, so it is 3 into 10 to the power -6, and M is having location at this. So what we have to apply? We have to apply same formula, E is equal to force per charge. If we have to take vector, we have to add the direction component AR cap. So let us put into formula. So E bar due to 0.2 on M. So first given charge, that is 3 into 10 to the power -6 divided by 4 pi epsilon naught. R square here is 7.28 whole square, and for AR cap, again destination points minus source point. So 3 minus -1, so it will become 3 plus 1 in x direction. Next plus, here we have this as -4, so -4 -2, so -4 -2 -4 -2, yeah, -4 -2 in y direction. Then plus remaining z direction is 2 3 AZ cap, and its magnitude, first one for x, it is, this one is 4 square, then second one is, say, -6 whole square plus -1 whole square. So after solving this, I will write down answer for your reference. It is 279.523 AX cap minus 419.285 AY cap minus 69.881 AZ cap. So this is the answer for B part. Now let us see for the C part. So let us erase this all. For C, what is the question? Now C, we have to find out the combined effect. A charge Q1, that is at P1 and P2, both combinedly how they are making the effect on this. So first let us see the diagram in 2D, and you have to imagine it in 3D. So suppose we have one point P1 here, and here suppose we have point P2, and somewhere else we have point M1. So what we have to find out? The effect of P1 on M1 and also the effect of P2 on M. So both of them combinedly applying some electric field intensity on this point M. So for that, what we have to do? Already we have calculated E for P1 and E for P2. If we take addition of both of them, we will get the answer of total E on M. So this E total is nothing but E1 plus E2. So we have already calculated these values. So we'll write down these values here for E1 and E2. For E1 we have 345.307 AX cap. Then next one we have 460.409 AY cap plus 230 minus 230 point just a minute. So this will be 230 . So this is 230.204 AZ cap. So now we have to plus E2. E2 just now we calculated, it is 279.523 AX cap minus 419.285 AY cap minus 69.881 AZ cap. So if we solve this, we'll get the total overall electric field intensity. So addition of these two will get 624.84 AX cap minus 879.69 AY cap plus 160.323 AZ cap. So this is the total electric field intensity due to E1 and E2. So next examples we will continue in the next session. Thank you. Have a good day.